Good morning, students. Welcome in next lecture of Math F242 Operation Research. So presently we have covered the four basic models of inventory management. So two are of back order allowed and two are of back order are not allowed. So in continuous of that, we have the following question. An item cost 200 rupees and it can be produced at the rate of 100 per month and the it is sold at the rate of 30 per month. The means what is this? This is the delivery rate. This is the demand because on the demand only we can sell, and it is the cost price. So it is given to you as a C note. The holding cost for rupees 20 per unit per month and setup cost is rupees 1000. So this is given to you as a C1 and this is a K independent of the quantity. Find the EOQ and optimum order cycle. Also find the TCU at optimum order cycle. It means what we have to determine. EOQ means we have to determine the Q star. OOC, that is the T naught star, and it is the TCU at Q star. Means optimal TCU. So this question belongs to the model 1 because delivery as well as the demand both are constant and there is no statement about the back order, so it is of model 1. So from question we can infer that A is equal to 100, D is equal to 30, K is equal to 1000, C1 is equal to 20 holding cost per unit holding cost, and C naught as a purchase cost. So for the model 1, we know that EOQ is what? It is the root of 2kd upon C1 into 1 minus d upon A. And optimum order cycle, that is the T naught star. T naught star, it is the EOQ upon demand, and and TCU is this much. So when we substitute the value of the KD, C1, C2, C naught, so you will get the EOQ as a 66 unit. That's simple. You can do the calculation. And OOC or T naught will come 66 upon 30. That is the 2.2 month. And TCU is equal to the 6916.52. So this is of model 1. Now here one important thing I have to convey about the lead time, that as the system stabilizes, the lead time for the sake of the analysis may always be taken less than the cycle length. Means here we have the cycle length, means at this period we repeat or we reorder. So when we have the stable system, right? When we have the stable system, at that time we assume lead time must be less than T naught. In practical, in practice, it may not be, but for the analysis, we have to assume lead time must be less than T naught. So here, let us have this example over this. The daily demand for commodity is approximately 100 units. So what is this daily demand? So it is given to you as a D. Item is produced locally. The setup cost is rupees 100 per production. So it is given to you 100 per production independent of the quantity, that is the setup cost. It is equal to K. The production rate is 200 units per day. It is given to you as a A. So here you can observe we have the constant demand and constant delivery rate with A greater than D. That is the required things. 200 units per day. The daily holding cost per unit of the inventory is 4 paisa. So here we have the holding cost, so it is equal to the C1. If the lead time is 12 days, it is given to you lead time is 12 days, so it is the lead time. Determine the economic lot size. Economic lot size means economic order quantity. That is, we have to compute the Q star and reorder point. Reorder point means T naught star. It is also known as the economic lot size or economic order quantity. So you have to compute. So in this case, first we will see A is constant, D is constant with A greater than D. So it is of model 1. So from the model 1, economic lot size is nothing. It is the economic order quantity. In this case, what are the given quantity, given parameters? K is equal to 100, A is equal to 200, D is equal to 100, C1 is equal to 0.04. So now suppose that lead time is the 12 days. So from here when we compute the EOQ, so first of all it is of model 1. Model 1. So for the model 1, EOQ is what? And root of 2kd upon C1 into 1 minus d upon A. So it is coming when we put the value of the kd, C1 and A. So here it is coming the 1000 units. And from here, when we compute the T naught, when we compute T naught star, so T naught star is what? Optimum order cycle or reorder point, optimal reorder point. So it is EOQ upon D, 1000 upon the 100, that is the 10 days. So if you see the graph, so it is of model 1. So it will be like this. So in this case, this is the reorder point is given to you 10 days. This is 10 days. This is 10 days. So reorder point is given to you as a 10 days. And here we have the S. And by maintaining the demand, by maintaining the current demand, we have to produce the 1000 unit in one run. 1000 unit in one run. Now, question is question is here the lead time is 12 days. So when the lead time is 12 days, so if at this point you require the item, please listen now carefully. Very important thing is coming. If at this point you have to restart your production, or this is your reorder point, but lead time is of 12 days. So it means when we have to reorder, if you require at this point, so we have to reorder 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then 11 and 12. It means you have to reorder. You have to reorder at this point, because the lead time is of 12 days. So you have to make an order 12 days prior than the actual point of requirement. Clear this part? It means it means the actual lead time, yeah, effective lead time, you can say effective lead time. In this case, the effective lead time will become lead time, that is the 12 minus 10. So always we consider the lead time must be less than the T naught, that is the 10. So when the lead time is more than the reorder cycle, or optimum order cycle, or the T naught, then take the difference 12 minus 10, right? So 2 days. So it is coming, the lead time is the 2 days. So at the means on the 8th day, in one cycle, on the 8th day, if you will order, then you will get the order after the 12 days. So actually you have to order on the 8th day, right? On the 8th day. So here when when the inventory level, when the inventory level means when we have to order, that is the small s star. So inventory level must be d into l, and d is what? It is the 100 into 2, that is the 200. That is the 200. So it means when we have the label, when we have the label of 200 item, so in this, in in these 2 days, right, we can utilize, we can fulfill the demand of 200 item. In this period we can utilize, so we can fulfill the demand of the 200 item. So when the inventory level is at 200, at that time we should reorder. So that is the s star. Means we cannot say s star is equal to 12 into 12 into or l, or that is the 12 into 100, 12 into 100, that is the 1200. Because in the production run you are producing only the 1000 item. If you are producing the 1000 item, your stock cannot be the, your stock cannot be the 1200. So that is the wrong approach, right? This approach is wrong approach. So in that case, we have to determine the effective lead time. And here the effective lead time is of 2 days. Clear? What is the effect? So it means, what is the optimum policy? What is the optimum policy? Optimum policy is reorder, reorder, reorder when inventory level, when inventory level is at 200 units. Inventory level is at 200 unit, and and one order is pending. One order is pending. When one order is pending, then you have to reorder. That is our, means at this point, at this point when we require the item, so at this, at this level you have to reorder. At this level you have to reorder. So at this point, at this point, whatever you have order here, whatever you have order here, that you have not received. So one order is pending, one order is pending, and current inventory level is 200 unit, that is the d into l. So at that time you have to reorder. So that is the optimum ordering policy. Similarly, if we have the L is equal to 22 days, 22 days, so in that case, uh, effective lead time will come, uh, again the 2 days, or you can say 200 minus 2 into 10, 2 into 10, that is the 2 days. So in this case, 2 days. So in this case, what is the optimum ordering policy? Uh, 200 200 unit plus 2 order in pending, 2 orders in pending. Clear this part? Clear, Ashwin and Bijen?
Yes,
Yes,
yes.
yes.
So here we have the effect of the lead time. Use the same value of dk c0 c1 of example 8.1. Assume infinite delivery rate. Calculate the EOQ, OOC, and TCU at the OOQ. So that is the that is our question, extension of the 8.1. Extension of the 8.1. In this, just you have to assume a tends to infinity. So if it is the a tends to infinity, so this is the model second. Model second. So by the Bilson formula, right? By the Bilson formula, you can compute the here EOQ as a 54.77, and OOC as a 1.826, and TCU is, right. So I'm not going in the calculation part. Just you have to recognize which model we have to use. So these are some question just for your reference from previous years papers. Right now we have the another model, model 5. So till now we have studied the model 4. In the model, in all the models, we have the static demand is constant delivery rate, either the infinity or constant delivery rate. Then after, whether back order is allowed or not allowed. So in that we have seen we have the most general model is model third. From the model third, we have derived the model 1, model 2, and model 4. Now the model 5 is extension of these models. Extension of these models. So here also first we studied the extension of the model third, and from there we drive the extension of model 1, model second, and model 4 as a special case. So model 5, in the model 5 that we have single item, static demand, that is the D, and here we have the important modification is the price discount. So in practice, when we purchase more item, more quantity, when we purchase any item in more quantity, so you get the discount. For example, if you produce more than 100 items, then the unit price is something. If you purchase more than 200 items, then unit price is little lesser. Then if you purchase more than 500 units, then unit price is more lesser. So and in that way we have the discount. So now we will study the model 5. Model 5 is nothing, it is the modification of model model third plus price discount, plus price discount. So if quantity ordered is large, there is price discount. Now purchase cost per unit of item, that is the C naught. Till now we have studied the C naught is a constant. It is in the price discount means C naught is stepwise decreasing function. C naught is stepwise decreasing function, that is the C naught q. C naught q is equal to C naught j when you are purchasing in the limit nj minus 1 to nj. Means here we have, if you say it is the C naught and it is the quantity, so let's say this is the n naught, n1. So it is the this cost. Then for the n2, it is this cost. For n3, we have this cost. For the n4, we have this cost, right? And for the for the means or you can say let's say n5. So here we have the this cost, and after that it will continue. So here you can observe that this is the unit cost. For example, if you are purchasing the 0 to 100, 100 to 200, 200 to 500, 500 to 1500, and 1500 to 3000, and if you are purchasing more than the 3000, then we have the different unit price. So here you can assume, let the unit price is 100, here the unit price is 90, here the unit price is the 85, here the unit price is 83, 85, here the unit price is 83, and here the unit price is the 80. Means we have the some limit. After that you cannot reduce the unit cost. So in this way we have the we have the price discount. So when we have the price discount, clear what is the meaning of the price discount?
Yes, sir.
Now during the derivation we have seen when we have done the model third. So in that case we have computed the TCU TCU QB. So in that we have the, this is the procurement cost. This is procurement cost. Procurement cost. This is your
Holding cost.
holding cost, holding cost, and this is your shortage
Shortage.
cost. Shortage cost. So if you notice, instead of the C naught, we have written the C naught Q. Whatever the quantity you are purchasing, If you are purchasing the 50 units, then we have the different TCU. If you are purchasing the 150 units, then we have the different TCU. If you are purchasing 750 units, then we have the different. So depending over the quantity, here we have taken the TCU. So in this case, what we can write, this can be written as C naught Q into D plus FQ. C naught D plus C naught D plus FQ, where FQ is what? It is the KD upon Q plus C1 Q1 minus D upon A minus B whole square minus B whole square upon 2Q1 minus D upon A plus C2 B square upon 2Q1 minus D upon A. So what we want? We want minimum TCU. We want minimum TCU. What is the nature of the C naught Q into D for the particular Q? For the particular Q, what is the nature of the C naught Q into D
Decreasing function of Q.
for the particular Q? If I'm saying
It
that
will,
Q is 150,
you said it will be constant.
it is the constant. So it is the constant. It means TCU is minimum when we have the minimum FQ. When we have the minimum FQ, then only right minimum FQ. So here it means from here what we have to compute? We have to compute the Q star. For the Q star, what we have to check? Del F by del Q. Del F by del Q must be 0 and del 2F upon del Q2 must be greater than 0. Here we have the function. Here we have the B. B is also the function of Q. So first we compute the, because in the model third we have seen, we have computed the del F del TCU by del B also. So first we compute the del F by del B, and then we have to check the del 2F upon del B2 is equal to uh, right greater than 0. So in this case, you have the some Q, right? Some Q or optimum Q. So here we will follow the that procedure. So first we compute the, for a given Q TCQB is minimum when B satisfy the following condition. When we say del TCU of Q comma B by the del B, it means it is equal to del F by del B, right? Del F by del B, because in this case, if you differentiate with respect to B, there is no B quantity in this part. So either you compute the del TCU by del B or del F by del B, both will give the same result. So and it will come this, already we have seen this derivation. So when we equate it to 0, you will get the B is equal to Q into 1 minus D upon A into C1 upon C1 plus C2. Q into 1 minus D upon A into C1 upon C1 plus C2. That you will get. And then if you see from here, if you compute the del 2 upon del B2, del 2 upon del B2, so here you have the C1 plus C2 upon Q1 minus D upon A. So here you know it is the positive, it is positive, it is positive, and since D is less than A, so D upon A less than 1, so this is also 1 minus D upon A is also positive. So this implies that this is greater than 0. So here we have the del TCU by del B2 or del F by no, del 2F upon del B2. Del B2 are del B2 is greater than 0. So from here, when we have the optimum value of B, right? Optimum value of B, and if you put that value of b at this point, right, at this place when we put the value of b, and at this place when we put the value of b, so here you have the tcu. Tcu now function of q only. You have put the value of b in terms of the q. So here you have the TCU as TCUQ as a C naught Q into D, KD upon Q, C1 C2 Q into 1 minus D upon A upon 2 into C1 plus C2. A means this derivation is exactly whatever we have derived for the model third. So now again it is what? It is the C naught Q D plus FQ, right? And now here it is written that FQ is equal to KD upon Q plus C1 plus C2 Q into 1 minus D upon A upon 2 into C1 plus C2. Now from here, if you compute the del Fy del Q, del Fy del Q, so del Fy del Q from the first one will come minus KD upon Q square, minus KD upon Q square plus C1 C2 into 1 minus D upon A upon 2 C1 plus C2, 2 C1 plus C2. So from here the Q will come. I am not saying it is the Q star. It is the optimal Q for the FQ, not for TCU, right? Not for TCU. It is the optimal Q only for the FQ. So Q naught will come. That I am representing as a Q naught. So Q naught will come root of, because when we put it is equal to 0, when we put this is equal to 0, so the Q naught will come to root of 2 kd up into C1 plus C2 upon C1 C2 into 1 minus D upon A. So this is your Q naught. This is your Q naught. So now what is the situation? Let us revise the situation. Here we have n naught, n1, n2, n3, n4, and so on. This is the graph of the C naught, that is the C naught 1 or C naught 0. Right? This is the graph of the C naught 1, C naught 2, C naught 3, C naught 4, and C naught 5, and so on. Right? So this will continue. Now, what is the TCU? TCU is C naught J into D plus FQ. So I'm saying that at the Q naught, FQ is minimum. So when we know that what this is the graph of the FQ, and at the Q naught it is minimum. So when we add these two graph, above graph is of C naught J, into D, that is the constant, plus FQ, plus FQ. So what will be the shape of the resultant graph? What can be the shape of the resultant graph? Let's say it is the Q naught, and I'm saying that Q naught Q naught belongs to N2 to N3. N2 to N3. So what can be the shape? So first we see, let's say it is the N2 and this is the N3. Now please see carefully. So if you combine C naught C naught 3 into D plus FQ between N2 to N3. Can you tell me what will be the shape if you combine these two? Can you tell me what will be the shape? Because the shape is convex, shape of the FQ is convex in this interval, and C naught J into D is constant. So constant into convex will be the convex, remain convex. So its shape will be like this. Clear this part? Now, if we have the N1, here we have the N1. So between the N1 to N2, here we have the constant plus decreasing. Constant plus decreasing. So constant plus decreasing will be the, it is the decreasing. It is the decreasing. Clear? In the N0 to N1, in the N0 to N1, what is the shape? C0 1 is constant, into D is also constant. C0 1 into D will become constant, and FQ is decreasing. FQ is decreasing. So here the shape will be, here the shape will be decreasing, right? It is the decreasing. Now when we have graph from N3 to N4, N3 to N4, here we have the N3 to N4. So in this case, what will be the shape? Here the shape of FQ is, shape of the FQ is increasing, and here the C4 is constant. So it's okay, the graph will come, the increasing, the graph will come, because constant plus increasing, the graph will increasing. But can you tell me what, from where I should start? Graph is increasing, right? It may be of any place, right? It may be of any place, means graph is increasing, but it depends, because the C04 is lesser than the C03. So what is this value? What is this value? It depends over that, what will, from where we should start, from where we should start. Similarly, in the N3 to N5, in the N3 to N5, if we have, means N4 to N5, in the N4 to N5, let's say one more we draw, right? So in the N4 to N5, again we know that C05 is constant and FQ is increasing. So again in the N4 to N5, graph is increasing, but we do not know from where it will start. Clear? So and similarly on the right hand side, we cannot say from where it will start. So if I want to say, for period N0 to N3, for the period N0 to N3, for this graph, for the period N0 to N3, where we have the minimum TCU. Up to here, where we have the minimum TCU
Q naught.
at the Q naught. Minimum TCU at Q naught. Minimum TCU at Q naught. For period N3 to N3 to N4, where we have the minimum TCU at
N3.
N3. Then for the period N4 to N5, minimum TCU at
N4.
N4, right? At N4. It means for N4 to for N5 to onwards, minimum TCU at N5. So from this, what can be the conclusion of where we have the minimum TCU? From here, we can say minimum TCU can be at any point, right? At the Q naught, N4, N5 means Q this diagram. If you compare, so this is at the N5. Minimum is at N5. Star Q star. Q star is what? Economic order quantity. So Q star can be any point among Q naught and left side of and left limit or you can say left side of right limits, or you one more, or you can say it is the left limit of right interval right interval, right? It is the left limit of the right interval, either Q naught or left limit of the right interval. So when we have the Q star, so after noting the Q star, all this we have explained here, right? So in the C naught D, a non-increasing step function for all Q, so that you can understand from here. So in this case, the Q star will occur either at Q naught or at the left end of the interval, right? Which lie to the right of the Q naught, So after having the Q star, we can compute B star, economic back order quantity, as C naught into Q star into 1 minus D upon A upon C1 C2, because just now we have derived now B is equal to this in terms of the Q. This is the B is equal to Q into 1 minus D upon A into C1 upon C1 plus C2. So just you put the optimum value. So here you will get the optimum value. And T naught star is the Q star D. Q star D and TCU. TCU will be the right where we have the minimum TCU. It means here what we are seeing, Q star. Q star is nothing, any point among Q naught, N3, N4, N5, or Q naught or left limit of the right interval where 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 TCU is minimum. TCU is minimum. So in this way, we can compute the economic order quantity and the minimum TCU. Minimum TCU. So you can see this this Q naught. Q naught. This Q naught is what? It is exactly same as whatever the Q star in the model third. Q naught is exactly same as whatever we have in the model third, right? But it is not a Q star. Due to the price discount, it is not a Q star. Expression is exactly same. So from here, if you have to drive for the model 1 with price discount, at that time Q naught will come this 2 kd upon C1 C1 into 1 minus D upon A, means no back order allowed. Similarly, for the model 2 Q naught is root of 2 kd upon C1, no back order, no and delivery is infinite. Delivery is infinite. So Q naught is this one. And for the model 4, Q naught is Q naught is the root of 2 kd into C1 plus C2 upon C1 C2. So
So,
from the, yes,
can you show the previous slide once? The Model 2 with price discount. Yes, sir. Thank you.
means we have the same expression. Only this is the C naught plus FQ for the model 2. In this, we have the C naught D plus FQ for the model 1, and here we have the C naught D plus FQ for the model 4. Now, important remark, if we have the very rare amount, for example, presently we have the bar between the Rus and Ukraine. So there what we have, if you want to purchase more items for storing, so what you have to do, instead of having the price discount, you have to pay more for the more quantity. Generally, when we have the item in black, when we have to purchase the item in black, for example, you have to purchase the gas cylinder in black. So what you have to do, if you want to purchase the one cylinder, it's okay. But if you want to purchase the 5 cylinder, so you have to pay more. Unit price will increase. If you want to purchase 15 gas cylinder, for example, in marriage, so you have the unit price will increase. So instead of the price discount, now price is increasing. As we have to means purchase the more item, the price may increase, but FQ will be same. FQ will be the same. At that time, what will be the Q star? Logically, you use the logic. So what will be the Q star? Either the Q naught, means we have the shape like this. We have the shape like this, and from here we can have from any point. From any point. So either it is the Q naught or right limit of the left interval. Right limit of the left interval. Right limit of left interval. Right limit of the left interval. So uh, you have to take care whether it is of price discount or it is of black marketing. So accordingly, you have to determine the Q star, and after having the knowledge of the Q star, we can determine the what is the B star, T naught star, and TCU star. So let us understand this concept by the question. The demand of the product is 500 units. that is the D per week, and delivery rate is 1000 units per week, that is A. If the ordering cost is rupees 100 per order, that is the independent of the quantity, it means it is the setup, it is the per order. The holding cost is rupee 1, holding cost is rupee 1, it is given to you as a C1 per unit per week. Calculate the TCU and optimum order cycle. Optimum order cycle means T naught star, assuming that no shortage allowed. No shortage allowed means here we have the B is equal to 0 and C2 tends to infinity. So when no shortage allowed, it means either it is of model 1 and model second. But here the delivery is given as a constant rate. So here the constant rate. So here from 500 to 1000 you have to pay 38, and if you are purchasing more than 1000, then you have to pay 35. It means what we have, let's say it is the 100, let's say it is 200, let 300, 400, 500, 600, 700, 800, 900, and 1000 and 1100, 1100, 1200, 1300, 1400, 1500, 1500. And let's say it is the 50, 40, 40, 45, 40. This is the 35, and this is your 30. So if it is less than 100, then it is 50, then it is 45, then it is 40, then it is 38, and then we have the 30. So this is the price discount. So for means this question belongs to model 5. In model 5 also it is model first plus price discount. Model first plus price discount. So for the model first, we have seen what is the formula. Q naught is root of 2 kd upon C1 into 1 minus d upon A, and TCU is C naught J into D kd upon Q, because only we have the procurement cost plus holding cost, kd upon Q plus C naught Q into 1 minus d upon A upon 2. So here we have the following information. Following. So from here we compute the Q naught as 447. Q naught as 447, and this 447 belongs to this interval. 447 belongs to this interval 200 to 500. So it belongs to 200 to 500. So you can notice left side is closed, right side is open. So it belongs to the 200 to 500. It means Q star can be the either the Q naught. Q naught is what? 447, or 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 left limit of right interval, left limit of right interval. So q star can be either the 447 or 500 or 1000, left limit of right interval. So where tcu is minimum, where tcu is minimum. So we uh, compute here we compute the tcu at 447, tcu at 447, tcu at 500, tcu at 1000, using the formula C naught J into D 1 by 2 1 by 2 C1 Q into 1 minus D upon A plus KD upon Q. So at this place unit price is given to you as 40, 38 and 35. So one we put 40, 38 and 35 C naught G, and corresponding Q will be 447, 500, 1000, and here we put 447, 500 and 1000. So here you have the TCU at Q is equal to 447, TCU at 500, TCU at 1000. So where we have the minimum? So this is your minimum. It means Q star will come as a 1000 units. Q star will come as a 1000 units. Clear? So as we compute Q star as a 1000 unit, so using the basic formula, TCU will come this, and optimum motorcycle T naught star as a Q star upon D. So it will become the 2 peaks. So in next class we continue from here.
Thank you, sir.
Anything you want to ask from here? Means here we have to compute the TCU at the 3 points, at the Q naught, at the left limit of the right intervals.
Okay.
Okay.